Welcome to Logic Dogs. Meet Bella and meet Theodore. They're best friends. If Bella goes on the bed, then Theodore goes on the bed. Instead of writing this sentence over and over again, in logic, we have a shorthand way of expressing the same exact sentence. And here it is. And what that means is, if P is true, then Q is true. It's the same sentence. If P is true, then Q is true. And in our case, the P is Bella goes on the bed, and the Q is Theodore goes on the bed. So, if Bella goes on the bed, then Theodore goes on the bed. Bella goes on the bed. What happens next? That's right. Theodore goes on the bed. So, you thought you just saw dogs jumping on the bed. What you saw was an illustration of Modus Ponens. Modus Ponens goes like this. If P, then Q. We have P, thus we must have Q. What if all we know is that Theodore goes on the bed? Does that mean that Bella went on the bed? What do you think? Are you thinking that Theodore sometimes goes on the bed without Bella? You're right. Theodore goes on the bed when there are treats on the bed, or when he's sleepy. So just because he saw Theodore go on the bed, it doesn't mean that first Bella went on the bed and that she's up there, because she might not be. What if Theodore does not go on the bed? Could it be true that Bella went on the bed? Think about that one. That can't be true, right? Because we know if Bella goes on the bed, then Theodore goes on the bed. So if Bella had gone on the bed, then Theodore would be there too. Now, we used a big X through the Q to show this does not go on the bed. In logic, we really write it with a little squiggle in front of the Q, and that means not Q. So little squiggle, Q, means not Q. And in our case, that means Theodore does not go on the bed. So when we're given these two things, like we just were, we know that not P is also true. Now, here are two vocabulary words for you, antecedent and consequent. The letter that comes before the arrow is the antecedent, in this case P, and the one that comes after the arrow is the consequent, in this case Q. So for that same argument we just saw, we could say it's a case of denying the consequent. If you look at step 2 there, we're saying not Q. We're denying the consequent. Look. Q, the consequent. Not Q. Didn't happen. We're denying it. So this is a case of denying the consequent. It's a valid argument, otherwise known as Modus Tollens. Here's an argument we saw saying that we have the consequent. We're affirming the consequent, but we're saying that that proves the antecedent, right? In this case, that would mean that we have Theodore, we saw him, Theodore went on the bed, and we're trying to say, therefore, that means that Bella went on the bed. And that just isn't the case. So, this one is not a valid argument. This is another one we saw. It's the first one we saw. This one's called affirming the antecedent. If Bella goes on the bed, then Theodore goes on the bed. Now we affirm the antecedent. Bella went on the bed, and therefore we know Theodore must have gone on the bed too. And this one is not a valid argument. This one is similar to the one we just saw, but in this case, we're denying the antecedent and trying to prove that that means that the consequent didn't happen. So this case is not valid because we know that sometimes Theodore goes on the bed without Bella going on the bed. And that was it for Logic Dogs number 1. I hope you enjoyed it. And if you want to see a shorter version, we're putting up another version that's a little bit shorter and not so many logic symbols and just has you thinking about these two dogs and the rules in the world of the Theodore and Bella world and what could be possible. Thanks for watching.